Hi, and welcome back to our Dispense Connection video series. I'm Faye Stübing.
And I'm Thomas Sino, and today we're talking all things cartridges.
Cartridges and single-use components that are generally used in applications when smaller syringe barrels, anything 70cc and less, won't suffice. At Nordson EFD, our optimum cartridges are available in 2.5, 6, 12, 20, and 32 fluid ounces. These come in clear, which are suitable for most applications, amber to block both UV and visible light wavelength, and black to provide complete light blockage for light-sensitive fluids. We also offer a white cartridge, which has better frozen temperature resistance.
Cartridges can be used for both manual and automated applications. Cartridges used for manual applications are primarily focused on non-precise applications, such as feeding a screen printer with solder paste. One of the primary purposes for cartridge reservoirs is to feed a dispense valve, typically for semi-automated or completely automated dispensing applications, such as on a tabletop robot you see here. For semi-automated and automated applications, the primary goal is to use a reservoir that has enough fluid to last a shift. Typically, someone will use a 6-ounce cartridge or larger to accomplish this task. The other reason to use a cartridge as a fluid reservoir to feed a dispense valve is when the fluid is very thick and non-pourable.
Outside of the cartridges themselves, retainers and pistons are also important pieces of the dispensing cartridge system. Let's talk about pistons next. Our optimum cartridge pistons are molded from high-density polyethylene and are especially beneficial when working with higher viscosity, non-pourable fluids. These pistons are tight-fitting, helping to wipe the sidewalls of the cartridge during dispense, reducing fluid waste, lowering production costs, and simplifying the disposal of used cartridges. Since dispensing with cartridges usually means they are subjected to constant air pressure, dispensing without a piston could cause the air to blow a hole in the center of the material and lead to inconsistent dispensing. Next, we have our optimum retainer systems. These are molded from a high-tensile clear plastic and designed to fit tightly over a cartridge to help hold the pressure feeding in from an automated system. With cartridges, these are under constant pressure, and with thicker fluids, when you're dispensing, sometimes this can reach 80 psi. Without a retainer system, a cartridge could bulge under pressure, causing oozing and drooling. The retainer system eliminates this by fitting tightly and preventing the cartridge from bulging. We also designed ours in a clear plastic so it's easy to see the fluid line, so you always know how much fluid you have left to dispense.
Filling a cartridge can be accomplished by either bottom filling or top filling. For low viscosity fluids, you can easily pour the fluid into the top or large opening of the cartridge reservoir. For very thick materials, bottom filling tends to be the best solution. Bottom filling can be accomplished by using some type of high-pressure pump system to fill the cartridge from the bottom. If you're filling a very thick, non-pourable fluid from the large opening in the cartridge, you will most likely create air pockets and air gaps in the fluid. Having these air pockets in the fluid will create inconsistent dispensing results. If this happens, your best bet is to either centrifuge the cartridge or put it in a vacuum chamber to get rid of the air. So that's it for today. I hope you learned a lot about our cartridge reservoir systems.
And we look forward to seeing you in our next video.